Next up, we'll be simulating airplane flight, which also uses Bernoulli's theorem to work. In this presentation, we picked this specific design as it allows adjustment towards the tail flap. This is a normal, straight flight. Next, we adjust the tail flap of the paper plane, folding it slightly upwards. As you could see, the paper plane climbs upwards. When the flap is flat, the airflow on top and bottom of the flap are equal, thus no external force is created which would shift the paper plane's direction. But when we fold the flaps up, that's another story. When the flap is folded upwards, the cross-sectional area above the flap decreases, while the lower part increases. Here we have the air flowing at faster rate than the lower part of the flap. You are to be reminded that velocity is inversely proportional to the cross-sectional area, thus the smaller the cross-sectional area, the faster the velocity. Now let's look into the Bernoulli's equation. In a system, this whole term equals to a constant. Rearranging the equation, we get this. As the velocity increases, in order to compensate, the pressure decreases. This creates a lower pressure section on the top and a higher pressure section at the bottom of the flap, creating an external force, which pushes the plane upwards.